Yeah, thanks for taking the time to listen to this talk. It's always a bit difficult going after someone like Ben the Carman. But yeah, we're going to do a little detour down Lightning Lane. Hopefully I can get you enthusiastic about working on Lightning. So my name's Connor. I work at Spiral. Spiral's an initiative at Block. We support open source Bitcoin developers through grants and through working on projects like the Lightning Development Kit. So I'm going to basically go through, so actually, show of hands, who's actually heard of the Lightning Dev Kit? All right, cool. So we've got a crowd that's quite familiar. So hopefully I can elucidate what it's all about to some of the newbies as well. So yeah, we've just heard a lot about Lightning from Ben. So the Lightning Network, yeah, scales Bitcoin by making it possible for anyone, anywhere to send fast and cheap payments. You know, at the heart of it, we have these payment channels that aim to kind of compress and condense transactions between peers. And Ben just showed us some maths that shows that, you know, we can only scale to a few orders of magnitude above what we currently have on chain. But let's talk a little bit about the actual developer experience with regards to building on Lightning. So my team, we spoke to a few years ago, a number of wallet developers before deciding to work on LDK. And we learned that they faced many challenges with building on Lightning. We learned that building on Lightning was a very rough experience, specifically if you want to create experiences in mobile environments. Before LDK, if your team wanted to, integrate Lightning functionality into, let's say, a mobile application, you most likely had to modify one of the existing implementations and make it suitable for mobile devices or mobile constrained environments. Current implementations are good. They're like great out-of-the-box node solutions, and they provide like these really good RPC and HTTP interfaces. But ultimately, they are quite targeted for server environments. So if you want to turn like an on-chain wallet into like a unified wallet experience, unified balance, or if you want to source Bitcoin blockchain data from a third-party server using like Explorer or Electrum, and you want to do this on resource-constrained devices, it can be quite complex and time-consuming. And maintaining a Lightning implementation is very complex, and the maintenance costs tend to increase over time as your code bases age and the new use cases emerge with different performance and security kind of trade-offs. So yeah, standalone Lightning node daemons don't allow for much customizations ultimately, and developers with complex architectures don't necessarily have the ability to like modify those implementations. So yeah, let's talk a bit about what LDK is then. So LDK is a toolbox that provides developers a convenient way to build a Lightning node from scratch and create custom experiences. So it's important to note that LDK is not a daemon itself, but rather it is a full implementation with all of the Lightning features that you want, but it's actually written as an SDK. So the core SDK is written in Rust. And we've created LDK to work in multiple languages with like this API first approach, and it's designed to ultimately run at the application layer. So this API approach means that developers are pretty much just required to call out APIs, and we have like a set of modules or components that developers basically have to plug into. So for example, we have something called the persist trait, or if you're more familiar with like Java, like an interface which is responsible for determining how you back up channel state to disk before progressing through the Lightning state machine. And and you don't need to, basically, you don't need to run your own Lightning implementation from scratch. You can basically modify an existing one and plug into all of the LN functionality that already exists. So let's talk a bit about who's using LDK. The projects you see on the screen ultimately chose it for its flexibility and the ability to cater to different architectures without sacrificing security. So like I said, it has the ability to run in almost any environment. So you've got stuff like HSMs, hardware security modules, or embedded devices. This is something the VLS project is doing. So if you was at the workshop yesterday, you would have seen an example where you are able to ultimately run a Lightning node on an embedded device with very specific spending policies and be able to manage keys in a secure enclave, and then have some server stack with its own TCP, ICP connections, and basically pipe that through to your embedded hardware over like a serial cable, for example. And yeah, just to go through quickly some of the projects. So we just heard from Ben, Mutiny, one of the first self-custodial wallets to run directly in the user's browser. So they've written it in Rust and compiled down to WebAssembly to enable that to happen. So that's fantastic because we don't have to rely on Google Play Store and the Apple Store and stuff like that. So it doesn't require users to download any software. And then we have Cash App, like very popular payments application in the US. They're using LDK as their Lightning implementation, primarily for its customization as well. And then we have stuff like Lexi, which I don't know, many people in here have heard of it, but it's also planning to be a self-custodial Lightning wallet that runs the user's node directly in the cloud on a secure HSM or SGX. And this is great because it solves the offline receive problem because you've got a node running in the cloud 24/7. Yeah, so just to elucidate a few more points on LDK. So we talked a bit about like its flexibility and customizability. So it is like truly like environment agnostic, many flexible modules, multi-language. So we support Rust, Kotlin, Java, C, JavaScript as well. It's very powerful and high performance, so it's written in Rust. I think a lot of developers that I speak to, they tend to quite like Rust because you get an improved developer experience, but you still get kind of fine-grained control over memory and performance and things like that. So Rust is doing good things in the developer community at the moment. And yeah, it's versatile as well. Like we just saw on the previous slide, there are a number of different architectures that are enabled by LDK. So we've got non-custodial wallets or enterprise HSMs and LSP and routing nodes of that nature. So it really just depends on what you want to build. It's important to note here as well, so LDK is a public good. We're building a sustainable open source project that is welcoming to new contributors, beneficial to users, and it's not relying on any single funding source. The LDK maintainers spend like a significant amount of time reviewing code, answering questions, writing documentation, and we're always like welcoming to new contributors. So let's just do a very quick deep dive, or well, semi-deep dive into some of the architecture. Hopefully you can kind of see that. So this is just like a bird's eye view of how LDK works. So like I mentioned, it isn't a daemon, but it is an SDK that gets compiled down and run directly in your application. It is environment agnostic, so it knows pretty much nothing about things like your networking stack, the Bitcoin blockchain, data storage and persistence. All of these things are customizable by the application developer themselves, and you are able to provide these components depending on what architecture you're trying to go for. And we do provide a few default implementations as well. So for example, on the kind of left side there, we've got monitoring the Bitcoin blockchain for things like confirmation of funding transactions, and this can be done in like various ways. You can hook into an Explorer or Electrum instance, or if you're running a Bitcoin core node, you can do that. Or if your project is aiming for something that's a bit more privacy preserving, you can opt for compact block filters as well. And we just provide an interface for that, and we also provide an interface for stuff like broadcasting transactions, so broadcasting your funding transaction and waiting that minimum amount of time before your channels become operational. We also don't know anything about the entropy used for your Lightning keys, so we pretty much just take like a 32 byte seed, and that's used as a bit32 extended key, and we just derive keys from that. So that enables like a simplified, unified wallet experience, in that the entropy used for LDK can be controlled within that initial mnemonic, and then users don't have to back up multiple things. They only have to back up that one private key securely. And then we have the data storage portion of it. So we have asynchronous and synchronous persistent component for managing channel state. And like the LDK will not progress if this state is not backed up properly. And then on the kind of bottom right there, just want to note that we have this kind of event-based architecture. So throughout the kind of the life cycle of your application, you'll be required to handle various events. Some are like notification-based, so LDK just tells you a channel was closed, and then other instances are actionable. You have to do an action. So for example, funding generation ready when your funding transaction is ready to be broadcast to the Bitcoin blockchain. So just want to talk on a little bit about this as well. So one of the first things you do when you're building on top of Lightning is you need to connect to peers before you start building your own Lightning node, and this is handled in LDK with the peer manager. This basically just handles everything like connecting to peers and exchanging all the necessary gossip messages. It also communicates with the Onion messenger that's responsible for sending and receiving Onion messages for things like Bolt 12 offers. And it also speaks to the peer-to-peer gossip sync, handling messages such as updating to peers and announcing channels, things of that nature. It's not represented on this diagram, but we also have a protocol called Rapid Gossip Sync, which enables you to offload some of the syncing of the network graph to a kind of semi-trusted third party and receive this in a nice compact manner, such that you can find a path to a recipient fairly quickly. And I mentioned that earlier as well, so users need to implement their own networking stack as well. So ultimately, LDK doesn't know anything about your networking stack. You just need to provide the kind of raw TCP IP information to LDK, and like we kind of magically handle the rest. Quickly touch on the channel manager as well. Quickly touch on, is that change? Yep. So quickly touch on the channel manager as well, because that's at the heart of what you'll come across when you work with LDK. Ultimately, this needs a way to persist like channel state to disk, so you can persist to disk. You can do it in the cloud or some other type of storage solution. We do provide a default solution called the KV store, which is like a key value store implementation as well. It's got ways to broadcast transactions to the Bitcoin network as well. Listen for new blocks and monitor stuff like unilateral closes, penalty and justice transactions, all of that good stuff. What else here? Oh, and fee estimation as well. So we provide an interface for doing fee estimation. We'll see like a short code snippet of how that works as well. So you can do that via a Bitcoin core node or third-party services, mempool.space, that kind of thing. And kind of like the mental model here is kind of the channel manager handles most of the off-chain stuff, I guess, and the channel monitor, as you can see just next to it, handles a lot of the on-chain stuff. So finding out about the state of your channels, each individual channels, and these must be kind of updated each block before you can progress on to the next thing. It might be a bit small to see, but let's just go through like a very quick example flow for accepting an inbound channel. So let's say, yeah, we're a mobile application running LDK and we want to accept an inbound channel. Maybe it's like an LSP or something like that. We get an open channel request, LDK processes that, and then we get this open channel request, which is an event that must be handled by the user. And then we simply call accept inbound channel, which is a method on the channel manager. We also have the ability to accept zeroconf channels. I forget the name of the method, maybe accept zeroconf channel, I think, maybe. And then LDK sends an accept channel message to our peer. Our peer responds with a funding created. We sign that, and then we basically just start polling the Bitcoin blockchain for the necessary confirmations to make that channel operational, and then we exchange channel ready messages, and then we're kind of good to go. So yeah, very little interaction required from the app developer side, basically handling an event and calling a method, and yeah, you're kind of good to go. And this is just showing like how a payment flow works. So here we have LDK running on the app as a payer and as a receiver. So on the receiver side, we call the create invoice method. I think it's changed in recent updates to LDK's create invoice from channel manager, but for the purpose of this, it doesn't matter too much. So we create invoice, LDK generates an invoice for us. We send that over to our to the payer. The payer calls the pay invoice method. I think that's also changed to send payment. We do this kind of HTLC dance, and then the receiver has to handle the pending HTLC forwardable event and calls the processing pending HTLC forward method. So it's kind of like, it is quite intuitive in that way. Like we just provide the methods that you call within these interfaces. And then you handle a number of subsequent events as well. So like when the payment is received, or and when you've claimed those funds as well, there's a method that you call to do that. And then yeah, some subsequent events on the payer side, such as when the payment was successful, when the payment was sent, or in the case of an error, there's a payment failed event as well. Quickly skim through this. So this is just is like a quick code snippet of like what much of you'll be interacting with is like. This is a fee estimate, the fee estimator trait, and this has a method which requires you to determine what fees you want to return given certain scenarios. So whether you're closing a channel and you want to submit a certain fee rate, or if there's an on-chain sweep that you want to do, you can kind of determine that customizably in this trait. And yeah, this is just a very simple example of like an interface for broadcasting a set of Bitcoin transactions as well. But having said all of that, that is quite involved. Let's just look at the time here. That is quite involved, and it does require quite a bit of Lightning knowledge, protocol knowledge, knowing how to stitch everything together, knowing the best practices for what to do with regards to fee management, what to do with regards to backing up channel state, how to manage the on-chain and off-chain portion of the wallet. It is very involved, and we identified that, and so we created LDK Node, which simplifies Lightning integration in non-custodial mobile applications. So it comes with a lot of sensible defaults, especially if you want to build in mobile environments. So it comes packaged with ready-to-go modules. So all of those components that you saw in the architecture diagram, they are ready to go in the LDK Node solution. So there's a number of methods that you need to call in LDK. Like I think there's over, ultimately the library has over maybe 800, 900 methods. This is a really slimmed down and compressed version. So you maybe have 15 or 20 methods that you need to call to get this to get this going. And this also supports language binding. So again, you can write in Kotlin, Rust, Swift, JavaScript, Flutter, React Native, that kind of stuff. So hopefully people who are doing the hackathon can tap into LDK Node and get up and running quite quickly. And then the other side of things is, so this is Lightning development is tough, application services make it easier. LDK builders can work with commercial partners to self-host servers or do both. So there is a lot of infrastructure that is required of teams of app developers in order to get going. So you know, managing your own Bitcoin node or your own Electrum server, running your own rapid gossip sync server. What else? Hooking into LSPs or Lightning service providers. It can be quite a tall order initially when you're trying to get up and running. But the community have kind of identified that and come together, and there's a number of different projects working to enable developer infrastructure by providing LSP services, providing Explorer and Electrum instances, providing rapid gossip sync service that developers can just hook into and don't have the vendor lock-in necessarily. They can swap in between these solutions kind of interchangeably. It's still quite early days here, but we're hoping to see some of these kind of solutions roll out quite quickly to developers, and people can start experimenting. Let's see what else we got here. So just to let people know what's on the roadmap for LDK as well for the rest of the year, we have async payment, so making it possible for transactions to go through when the receiver is offline. This is a really exciting thing. We kind of have onion messages and offers and things like that are available in LDK now. So kind of one of the next phases is to introduce the asynchronous payments protocol. We also have splicing, so the ability to resize Lightning channels without closing and opening channels. We've got a whole host of performance updates and scaling channels per node and on the server as well, and the amount of data that's stored in channel updates as well. And then there is this kind of LSP evolution as well. So there's an ongoing effort to create an LSP spec, which will enable some of the projects you saw on the previous slides, but basically anyone to create their own LSP and have it interoperable and interchangeable with other LSPs and allow users to swap in and out of LSPs as well. And there is the Lightning liquidity crate that will enable developers to basically write and run their own LSP as well. So yeah, that's me. I'm pretty much out of time. If you want to follow the project, you can head over to lightningdevkit.org, that's where all our documentation is. Got cool blog posts up about our roadmap, and Jeff just released a really awesome blog post about Bolt 12. I encourage people to read that. Follow us on Twitter, Lightning Dev Kit, and then yeah, you can also head over to GitHub to find out what's going on over there. So yeah, thanks for listening, and I hope hope this gives you a bit of enthusiasm to to continue to work on Lightning. So thank you. Yeah.
Yeah. Yes, Conor, could you speak to the current use of Taproot in LDK and any of the plans in the future for using Taproot more?
Yeah, so we don't currently support Taproot channels, and yeah, per our roadmap, these are the kind of priorities at the moment. But yeah, it is something planned for the future for us. Yeah, we've identified that, and it's yeah, something that's coming a bit later on. It's just there's a lot to build, and it will be coming down the line. Yeah.
Cool, great.
Cool. All right. Thanks, guys. Thank you.